much for attending this presentation, and I'd like to thank the conference committee for the opportunity to come and present this. Yes, I'm going to start things a little bit and just go ahead and tell you what I'm going to talk about. It's something that's going on at the Svartsengi Geothermal Resource Park, and it's a process for producing sulfur-free CO2. Well, the first picture here shows you what you usually see, but if we cut away all the tourists, we can see the really exciting stuff going on. So this is the main idea of the holistic idea, as people at HS Orca would say. And before I take credit for this entire process, I would hurry up and say that the part that we deliver from Haldor Topsoe is the one emphasized here in red. And it's basically taking the non-condensable gases and converting the sulfur into a form that can be scrubbed out and re-injected into the well to keep the silica scaling down. So that's the main idea, and I'll come back to this later on. What we liked so much when we got into touch with HS Orca was this idea of the utilization of the non-condensable gases. And at Topsoe, we're really good at taking a gas and converting it to something else. That's really our specialty. We know nothing what goes on underground, we should say. So it is mainly gas conditioning and converting with catalysts. If you look at of the non-condensable gases, it's typically carbon dioxide, hydrogen sulfide, and methane, silica, and other impurities, what we just heard about. So it might not just be impurities. What we see from the technologies we have is that CO2 and hydrogen are most obvious candidates to harvest and use to make synthetic fuel. You can make methanol, also H2S, then you can actually produce sulfuric acid. What I'll focus on here is CO2 for greenhouses that can also be cleaned up further and used for food and beverage industry. And I would also say here, maybe it's not so good in this forum, but clean CO2 can also be used for enhanced oil recovery. We just forget that. The CO2 for greenhouses, well, you need some quantity, you need a quality, and it have to have the right value. And that there's a special case here in Iceland, because if there is more local CO2, then there will probably be more greenhouses, because it costs a lot to ship it to the island. If you want CO2 in greenhouses, well, depending on crops, you need up to 1300 ppm. Those of you who were on the tour yesterday to the greenhouse, they used around 1000 ppm to grow strawberries. The consumption of CO2 is around this 45 to 90 kilos per hectare per hour. And this would be reasonable sizes for a greenhouse. So adding this up, you can take a list at market prices for CO2 and see it becomes a lot of money to use. So for a greenhouse of 50 hectares, you would use 28,000 tons per year of CO2. The CO2 quality, well, in Holland, they actually have gas turbines just burning away gas to produce CO2, so you can buy tomatoes from Holland, which seems a bit crazy, but they also use, of course, the electricity and the heat from the gas turbine. And that gives a lot of pollutants like NOx, hydrocarbon slips, and CO. It's really a messy process. If you do it with geothermal non-condensable gas, you would have to go below these tolerant values, which is really what food-grade CO2, the levels for food-grade CO2 is. So CO2 from geothermal sources is really in spec, because there's no NOx, there's no CO, but the sulfur species needs to be removed, and that's what this project is about. Just a quick slides about our company. We were founded in 1940 and are still a family-owned company, and we operate globally. And we're mainly active within fertilizer business, gas conditioning, methanol production, synthetic natural gas, and we have various environmental technologies for removal of NOx and sulfur. We operate globally, as I mentioned, and have research centers and sales offices all over the world. What we usually do is we process design, we have the catalyst for the process we design, some proprietary equipment, and then technical service. So we don't really build the plants ourselves. That was a little bit about the company. To go back to the technology that we will be using for this project to remove the hydrogen sulfide. Hydrogen sulfide is really an obstacle in many cases for utilization of a gas, not only in non-condensable geothermal gases, but it can be used for, as mentioned, this technology for CO2 production. You can clean up gases in using gas engines, or you can even have dilute acid production. The technology that we're using is catalytic, so you will have a catalyst like this, where you have the H2S containing gas passing through, and it will get selectively oxidized to SO2 and water. And the reason you want it to be SO2 and not SO3 or elemental sulfur is SO2 is quite easy to scrub out with a condensate, or you can buy commercial sodium hydroxide scrubber and get rid of the SO2. You can find other catalysts on the market that can oxidize H2S, but you might end up with SO3, and you will have acid mist and corrosion in your system. Or you might end up with sulfur clocking, like elemental sulfur, in an uncontrollable way, so you really can't operate the equipment. So the really novel thing about this catalyst and this process is that you can selectively convert all known sulfur species in non-condensable gases to SO2 that you can scrub out and re-inject. And one really good thing about this technology, because there is competing technologies which is good for the geothermal area, is it's very ideal for remote location. It doesn't need an operator to stand by it all the time. The catalyst can last for like 2 or 3 years, even more. So you don't need an operator to put in a fluid or stir something. There's no valves to be changed. So it's quite simple in operation, and we have an extremely high conversion of H2S. So what we've recently started a project. This plant hasn't been built yet, but we're in the phase of getting it built. It's planned to be commissioned within a year or so. Is where we have this process here. That will be like the thing that Haldor Topsoe will deliver, and the rest of it is from HS Orca's side. And this idea of re-injecting the sour water to the well, and so you can keep silica scaling down, came from HS Orca themselves. And this would be like the gas composition that comes in. And the idea is that the clean CO2 can be piped to a greenhouse or any other use that's been mentioned during this conference. That can be methanol production or for the fish industry for drying. So the process itself is actually quite simple. You have an air blower that provides the air. You have the off gas and the feed effluent heat exchanger, and then you have the reaction going on where you convert it to SO2, and then you take it out to the scrubber. Quite simple. The business model around this, we offer it in different ways, but since it's a new technology, we offer it, as mentioned, with like no cure, no pay gas conditioning, so there's no upfront investment for this, and that's to enable more projects. So we would take the technical risk and say, if it doesn't work, you don't have to pay anything. And usually the end user would have to be responsible for site preparation, utilities, and operation. And we would make sure that the plant is working. Thank you.